All right, in this video, I'm going to talk about a complex system and center of mass. So in a complex system, we can describe its characteristics and its behavior using microstates and or macrostates. So as an example, for a microstate, we have the kinetic energy of a single gas molecule in a room. And the microstate in this example would be the temperature of the air in the room. So the temperature of the air in the whole room would be the macrostate in this example. So a microstate is the state of a small section, a small little part, and then the macrostate would be the state of a larger part. So the kinetic energy of a single molecule would be the microstate, and then the macrostate is the larger overall part. In another example, we have the microstate would be the velocity of a single star in the Milky Way galaxy, so a single star, and then the macrostate would be the velocity of the Milky Way galaxy itself. So the velocity of the whole galaxy is the macrostate. All right, so a macrostate represents the average behavior of a system. So we're talking about a whole system here. And the center of a mass is a macrostate. So it represents the average location of the countless or not particles in a system. So we're talking about all the particles in a system. So it could be countless, like the number of air molecules in a room, or it could be a number of particles that could be counted, which we'll look at some examples in a minute of actually just a few particles or a few objects that make up a group of objects that we can then figure out the center of mass of those objects. So for example, for figuring out the center of mass of, let's say, 4 particles in space. So here we have an XY plane, and we have 4 particles on this plane. So we have M1, which has an address of X1, Y1. We have M2, which has an address of X2, Y2. We have M3, which has an address of X3, Y3. And we have a particle 4, M4, which has an address of X4, Y4. And then we have the center of mass of all of these particles, which is right here, which has an address X, or center of mass, Y, center of mass. Okay, when we look at this mathematically, so we have, for X, we have the mass of 1 times the X position of 1 plus a mass of 2 times the X position of 2 plus the mass of 3 times the X position of 3 plus the mass of 4 times the X position of 4 is equal to the mass of 1 plus the mass of 2 plus the mass of 3 plus the mass of 4 times the X center of mass. So we've sort of we've factored out the masses and multiplied that by the center of mass, and that equals each of the masses times their individual positions in the X direction. So if we solve for the center of mass, we end up with M1 X1 plus M2 X2 plus M3 X3 plus M4 X4, all divided by the masses summed together. M3 and then M4. And so the X center of mass is the average of the X coordinates for all the X coordinates of all of the masses. Okay, so from before we had X center of mass is equal to M1 X1 plus M2 X2 plus M3 X3 plus M4 X4 all over M1 plus M2 plus M3 plus M4. And we can write this as a summation. So we have X center of mass is equal to the summation. We have index equals 1. So from 1 to 4, Mi Xi, that's over summation from index of 1 to 4 of Mi. So that equals summation from I equals 1 to 4 of Mi times Xi over M total. So that is the X center of mass in summation form. And we can do the same thing in terms of Y. So if we do Y, we have in the Y direction, we have Y center of mass is equal to M1 Y1 plus M4 Y4. And that's over M1 plus M4. And similarly, we can write this in summation format. So we have Y center of mass is equal to the sum from I equals 1 to 4 of Mi Yi over the sum from I equals 1 to 4 of Mi Y. Oops, that should just be Mi. Okay, so then that equals the summation from I equals 1 to 4 of Mi Yi over M total. So that's the summation of the X center of mass and the Y center of mass. So in general, we can say that the X center of mass in summation form is equal to I equals 1 to N Mi times Xi over M total. And then Y center of mass is equal to the summation from I equals 1 to N of Mi Yi over the total mass. So this is our X center of mass in general and our Y center of mass in general. Okay, now let's look at an example with an unbalanced barbell. So here we have a barbell. It's 2 meters between the two masses. So we have this mass, which is at 0 meters. We have this mass, which is at 2 meters. It's 1 meter in between. So we have a 50 kilogram mass here. The center of its mass is right here at 0 meters. We have the barbell itself, which weighs 20 kilograms. Its center of mass is here at 1 meter. And then we have the second barbell, or the second mass that's put on the barbell. Its center of mass is here at the 2 meter mark. Okay, So we want to figure out the center of mass for this unbalanced barbell. So we have our center of mass in the x direction is equal to the sum from 1 to 3 of mass I xi over mass total. So that's equal to, we have 50 kilograms times 0 plus 20 kilograms times 1 meter plus 30 kilograms times 2 meters. All that is divided by our masses. So we have 50 plus 20 plus 30 so that's equal to 20 plus 60 over 100. So we have 80 kilogram meters per second, or kilogram meters, sorry. There's no per second there. Kilogram times meters divided by 100 kilograms. So our kilograms cancel, and we're left with an x center of mass of 0.8 meters. So our x center of mass for this situation is 0.8 meters. So our center of mass for this barbell is somewhere about here. Okay. All right, and that's how you use center of mass summation to find the center of mass of a system of masses. This, of course, is just in the x direction. If you had both x and y directions, you would figure out the x center of mass, the y center of mass, and you put them together so that you would have the center of mass for the x and y directions.